starting right now.
Alright, so let's do this quick again. So the circulatory system or the cardiovascular system is the system of the heart and blood vessels. Basically, it has three major components, which is the heart, the blood vessels, and the blood. So there are two types of circulation in the circulatory system. We have the systemic circulation, which has to do with circulation of blood throughout the body, and the pulmonary circulation, which has to do with circulation of blood to and from the lungs. So pulmonary circulation is when the heart sends blood from the right ventricle to the pulmonary artery to the lungs, and then it goes from the lungs to the pulmonary veins back to the left atrium. So, I skipped. And systemic circulation is circulation of blood throughout the body. It starts from the left ventricle through the aorta, which is divided into the ascending and descending aorta, which you don't need to know. So basically, the aorta supplies blood to the body. The blood goes from the aorta to the body, where it gives off its oxygen, picks up carbon dioxide and waste, and then it goes from the body to the veins, to the superior and inferior vena cava, and then to the right atrium. Any questions?
Not a question, but a comment. We also need to know, while it's transporting oxygen, it's transporting nutrients at the same time.
Absolutely.
Definitely throw that out there.
Don't go without skipping perfusion.
No. I will not skip perfusion. So, since he mentions perfusion is the fact that you supply the blood, you supply the organs and tissues with adequate oxygenated blood to satisfy the cell's needs, each cell's needs. Alright, so when I said systemic circulation, when I put arteries, you see I put in parentheses systemic arteries, because there are two kinds of arteries. There are the systemic arteries and the pulmonary arteries. I made that distinction because the systemic arteries carries blood that is oxygenated or oxygen-rich blood.
No. Systemic?
Yeah, systemic.
Pulmonary.
And the systemic veins, I write it over there, like if you want, like to write it. The systemic veins carry oxygen deficient or oxygen poor blood, that is the oxygenated. Whereas the pulmonary arteries carry pulmonary arteries carry oxygen poor blood to the lungs to be oxygenated, and the pulmonary veins carry oxygen rich blood from the lungs to the heart to be distributed to the body. Did I lose anybody? Questions, comments, concerns?
Can you say that over again?
Sorry.
I heard you, but
which one?
Because I think there's a fault.
All right, so pulmonary artery carries oxygen deficient blood. Basically, blood that's been through the body that has already lost all its oxygen to the lungs to be oxygenated. And then from the lungs, the pulmonary veins carry oxygen-rich blood or blood that's been oxygenated back to the heart to be distributed to the body.
Yeah, I got that. No, because I thought you said the pulmonary veins. I didn't hear deficient in there, but I got it now.
Pulmonary veins carry oxygen-rich, not oxygen-deficient, oxygen-rich blood. Pulmonary arteries carry oxygen-deficient blood, or oxygen-poor blood, or deoxygenated blood, like however you want to say it, to the lungs. Does everybody get this?
Yes.
All right. Now, arteries are blood vessels that carry blood away from the body. It doesn't matter which artery it is, if it's systemic or pulmonary. If it's an artery, it's carrying blood away from the heart. If it's a vein, it is carrying blood towards the heart or to the heart. Does everybody get this? Now, I realize I didn't put capillaries. Capillaries are the type of blood cells that are located at the very end of the arteries, at the very end of the arterioles. Basically, the arteries subdivide into arterioles, which are smaller arteries that carries blood like through the fine organs or tissues of the body. Basically, at the end of the arterioles are the capillaries. So, what happened at the capillaries? The capillaries have very thin walls. Basically, these walls allow nutrients and oxygen to diffuse through the cells. They diffuse from the capillaries through the interstitial space, and then from the interstitial space through the cell membranes into the cells. And then carbon dioxide and waste carry the opposite process. So when the blood reaches the capillaries, there are two types of pressure, to which he said we don't need to know.
Hydrostatic, right?
Hydrostatic pressure and
You don't need to know that one. Ontoxic pressure.
oncotic pressure. All right, so we don't need to know that so much. I'm not going to mention. And then the capillaries, while being the end of the arteries, are the very beginning of the veins or the venules. Basically, capillary, you go from capillaries to venules, to veins, to superior and inferior vena cava before you reach the right atrium of the heart. Did I lose anybody?
Say it again.
So basically, capillaries. Capillaries are the very end of the arteries, right? You go from arteries to arterioles to capillaries, which have very thin wall to allow diffusion of oxygen from the capillaries to the cells and diffusion of carbon dioxide and waste from the cells.
So they branch out?
You see how he had the picture in which
The heart.
of the heart, like it's not the heart, the blood vessel where they like permeate and then they have like some sort of structure that looks like this.
It shrinks basically, right?
Go ahead. I'm sure I have something I can show you.
So from the arteries to the veins to the arterioles to the venules to the capillaries, is that what you're saying?
Yes. No.
No?
It's not to the venules to the capillaries. Yes. So basically it goes from arteries to arterioles to capillaries. And then from capillaries to venules to veins to superior and inferior vena cava.
I'm sorry, wait. Arteries to arterioles to capillaries. So from capillaries to venules to veins.
Wait, say it again?
Arteries, arterioles to capillaries.
Yes.
From capillaries to venules to veins to
Superior and inferior vena cava.
So it goes through all that shit before it even gets to the...
So basically that's the systemic cycle. Basically, that is a systemic cycle because if you include superior and inferior vena cava, it is the systemic circulation. Because there is no superior or inferior vena cava. There is no vena cava in the pulmonary cycle. Alright, so basically here, the capillaries. I don't know if everybody can see. Like this is small, but you see these blood cells, like where the blue and red joins?
Mm-hmm.
These are, they join at the capillaries. Yeah. So basically, the capillaries are the junction that links, that connects the two arteries, the two systems, arteries and veins, the two types of blood vessels. Because they carry opposite types of blood cells.
the venules go back to the...
The venules grow into the veins, which themselves come together into the superior and inferior vena cava.
So it's capillaries, venules, then veins.
Yes, capillaries, venules, veins.
And that's systemic.
Yes.
Okay. Let me see a picture.
Alright, so did I lose anybody?
No. I died. Oh, yeah. Oh, yeah.
No, like if you have any question, like it's the time to ask.
Any question?
No?
Any question?
Alright, so now this was all that we just talked about was movement of blood outside of the body. I mean outside of the heart. Now, the heart, which since we were watching the video, I wrote over there. So the heart is divided into a right and left side. What divides the heart into the right and left side is
Septum.
the septum. Now, after you know that, you know the heart has 4 compartments. The 2 top compartments are called the atria, or atrium for simpler for one. And the 2 bottom ones are called the ventricles. Now, the atria is where blood enters the body. Enters the heart, always. Doesn't matter if it's coming from the pulmonary circulation or the systemic circulation. Blood always enters the heart through an atria.
It can't enter anywhere else.
No. And the ventricles is always where the blood leaves the heart. Always. Now, the heart is still divided into 4 parts. Both compartments on the right of the heart have oxygen poor blood. Both compartments, both right ventricle and right atrium have oxygen poor blood. It doesn't matter. At any time, at any place, they always have oxygen poor blood. Whereas the left side of the heart always have oxygen rich blood. Which is why I want you to associate left side with oxygen rich or oxygenated or whatever you want to, that will make you remember it. And the right side with oxygen poor blood or oxygen deficient or deoxygenated, whatever.
So left is red, right is blue.
Which is why red is red. Oxygenated blood is always bright red, whereas deoxygenated blood is bluish red, which is why. And diagrams, they always show you a blue and red side, so to signify where you have oxygen rich and oxygen poor blood. Does everybody get this? Did I lose anybody? Shall I continue? Everybody got that?
Yes. So the red and blue, is that how the game started? Or is that how the game started?
Hmm?
He's talking about games.
I hope not, man.
It was like, okay, so you guys can do the right side of the heart. We'll do the left.
Oh, that's what I'm giving me a second. Now, I covered the heart.
That's one way to remember.
I covered the compartments.
Actually,
Okay, so one thing I almost forgot. The heart is the layers of the heart.
Oh yeah, the layers of the heart. That you need to know. It's gonna be
That
a
you
test question.
need to know.
So what?
Test question.
The heart has 3 different layers.
Epicardium.
Epicardium, which is the most outside layer.
Myocardium.
Myocardium,
Which is the
which
muscle.
is the muscle of the heart, which is another name for the heart.
And
And endocardium,
It was in the
which
leg.
is the inside layer of the heart.
now, like before you guys get into that, I want you to pay special attention to those names. Like I'm sure every single one of you is gonna like make it to the next part of like the EMT course. Like I have confidence. Every single one of you, like see how those 3 words keep repeating themselves over and over and over again, and that's because like in bio, you're gonna see that. You're gonna see the same. You know how they started us with medical terminology the first day? That's because they want us to have that type of vocabulary. So you have, we're talking about the layers of the heart, right? So you have epicardium, right?
Bless you. Thank you.
Now, this is what I want you to pay attention to. Where do we see this word?
Epidermal. What's up?
Epidural hematoma, epidermis, epi on top. You're gonna see that word over and over and over again. So when you see those words, always when they give you those names, look how break down the words, look for the definition, and you immediately know what it is. If I make something up, like endoplastic, I don't even know what endoplastic is, but I know it's endo, so it's gotta be inside something. You know what I mean? If you start using that logic will help you move forward. It will help you solidify any other knowledge that you have of bio. So whenever we start talking about other structures further down the line, and you start seeing epi, endo, epicardia, endo, you're gonna see that you already know what that means. It comes again when you're talking about the reproductive system, when you talk about how the muscles develop, the endoderm, the ectoderm. You're gonna see that. You're gonna see those words over and over again. So start like from now with that mentality of dissecting the words, the medical terminology within them is gonna help you visualize things better.
All right. So let's continue. So as the heart has 4 compartments, there is one compartment that is particularly stronger than every single other compartment, and that is,
You said it's what?
there is one compartment of the heart that is more muscular than every other compartment.
The left, right?
Yes.
Yeah.
Left ventricle.
Left ventricle.
The left side is more muscular, but the compartment that is most muscular is the left ventricle. Why is it most muscular?
It has the most pressure.
The most powerful pump.
And that's going
Why
to,
does it have the most pressure?
I don't know, because it's contracting the most.
It's got
No. You see,
Because I'm
all the
deformed.
compartments of the heart are contracted.
but
It has the most pressure because the left ventricle is the compartment of the heart that has contract to push blood all over the body, like from the top of your head to your big toe down your feet.
now speaking of pressure,
No,
like
I don't want to like.
no, because we're already in that subject. But you guys do need to know this. Like, that's gonna be another question. You already know the left ventricle is high pressure because it needs to deliver blood to the rest of the body, right? Then by comparison, the right ventricle is low pressure. So if it has blood pressure, how does it move across the body? Now you need to know about that. That is the venous system of the heart, or the oxygenated part of the heart, is the part of the heart that is assisted. Like it uses external assistance to circulate the blood across your body. And because it moves the slowest, it's also the part of your circulatory system that has the most blood. At any one given time, you have 70% of your blood is deoxygenated, 30% of that blood is oxygenated. So how does it move through assistance? It uses gravity. It uses the internal pressure from your thoracic cavities when you breathe in and out. It uses that pressure to move in and out.
It uses contraction of your skeletal muscles.
It uses contraction of your skeletal muscles. That's how this deoxygenated blood moves out. And that is also why Mr. Nuki said the veins are more dilated. That's why the veins are more dilated. Dilated means it's more open than the arteries. That's why he said when you cut a vein, the blood flows steadily. When you cut an artery, the blood flows
to the
down.
pressure.
That's why he mentioned that. So you need to write that down.
Right. So what was that again? I said the pressure. So the pressures are always higher in the arteries. It's always higher in the arteries and always lower in the veins. At any time of the day, your veins always contain 70% of your blood, and your arteries 30%.
Because it's higher, right?
Yeah.
Wherever it's higher, it's lower, but wherever it's lower, it's actually higher.
What do you mean?
Wherever the pressure is lower, that's where the most blood is.
Oh, I don't know if it's because of that, but like, I'm sure you have as much arteries as you have veins, right? But the pressure is always higher in the arteries, and I'll tell you why.
Okay.
Because the ventricle is pumping the blood, and the blood goes from the aorta to the arteries. So, which is why the pressure in the arteries is always higher than the veins. Which is why the arteries have bigger walls than the veins to prevent them from bursting. And what dissipates that pressure from the arteries when it goes to the vein is when the blood reaches the capillaries. When the blood reaches the capillaries, there is the hydrostatic pressure. Basically, the blood just hits the wall of the capillaries, and then there. So to prevent a backing up of the red blood cells, the brain the circulatory system has two mechanisms. Basically, the regular diffusion of the red blood cells and nutrients and water from the capillaries to the
Yeah, the capillaries go to the
What are
veins.
you talking about?
to the interstitial space.
Interstitial.
And then it has the arteriovenous shunts. Basically, to prevent the cells from backing up, it uses that shunt. And then these blood cells that uses the shunt don't use their oxygen, and then they go back to the major vessels. All right. So before I reach all of this, I don't want to forget. So
But break down the system of the capillaries a little bit more. The shunts. Break down the shunts a little bit more.
all right. So what are the shunts? Arteriovenous shunts are basically bypasses to the capillaries. You know what a bypass is? Basically, it skips it. It goes over it. It goes around it. Basically, it does not use it. Whereas the capillaries, you have the hydrostatic pressure that is pushing water outside of the capillaries. Basically, because of that, red blood cells and nutrients diffuse. I mean, not red blood cells. Oxygen and nutrients diffuse from the red blood cells, from the red blood cells into the capillaries, and then from the capillaries into the interstitial space and to be diffused.
You're forgetting the
to
sphincters.
the,
The sphincters.
the sphincters are in the veins. I'm
No,
getting there.
in the arterioles, or small muscles and arterioles that can be open and closed.
Wait, say that again?
It says right here, sphincters are small muscles in the arterioles that can be opened or closed. That's what it
Yes.
says.
They're alright. So sphincters are all over the place, essentially.
Oh.
They're in your arteries to prevent backing up. They're in your veins since it has less pressure to prevent it from going back to. So, and then you have the oncotic pressure. That is
You said
what
we didn't need to know
helps
that. Right?
the blood. Huh?
You said we didn't need to know that.
No, you don't need to know that. Like he said to elaborate, so I was elaborating.
Okay.
But I didn't want to leave the heart just yet. We know there are 4 compartments in the heart. So how do the compartments connect to each other? So that's when we have the valves. There are 4 main valves in the heart. So when the blood is coming to the heart from the systemic circulation, it enters the heart to the right atrium. So how does the blood go from the right atrium to the right ventricle? It passes to the tricuspid valve, which is called
What?
Say what?
what is the type of valve? The tricuspid valve. What is the type of valve is it? What type of valve is it?
No idea.
The tricuspid valve is an atrioventricular valve.
Yeah.
He said that in class. You need to know that. Both the tricuspid, the bicuspid, or atrial valve are atrioventricular valves.
Now, here's what you're gonna.
Huh?
Arterioventricular.
Alright, so basically, both the tricuspid valve and the bicuspid valve, for which another name is the mitral valve, are atrioventricular valves because they're between an atrium and a ventricle. Do you get it? It's like a door. It's a one-way door, though. Blood cannot go
Back up.
from ventricle to an atrium.
Now,
It cannot.
Here's the reason why, and this is also going to be a test question. The reason why,
Chordate tendinate.
like you guys saw in the video, you guys saw that the ventricles, the valves in the ventricle, the bicuspid and the tricuspid valve had these kind of little fibers connecting them. You see, so here's your tricuspid valve, and here's your little fibers connecting them. What prevents this valve from basically inverting upwards and letting the the backflow, like the blood flow back to the atrium, is this little thing which are called the chordae tendineae. That word you need to know.
What is it? What is the definition of that?
The chordae tendineae, basically they're filaments that are attached to the layers of the valve that prevents them from inverting, basically shutting the door, preventing the door from going two-way door. You know how?
It's fibrous.
Chordae tendineae.
Chordae tendineae. Let me find you the right. Basically, it says here there are thin bands of fibrous tissue that are attached to the valves and the heart and prevents them from inverting. That is the exact definition.
Don't forget about the muscle that holds it in place.
What do you mean? Which one?
The capillary muscle. At the end of the tendinate, you have the capillary muscle hold it down.
Yeah, about the thyroid muscle. You're right.
FBI hired you.
All right. Did I lose anybody as so far as I'm here? Everyone is here.
Yeah.
So what are the four major valves? So basically, what are the two major valves on the right side of the heart?
Mistral?
No.
You said
The two major valves on the right side.
right side?
That's
Oh, it's going to be that pulmonary, what is it, the pulmonary valve to lead to the lungs. You have the
Before that, you have the tricuspid valve,
tricuspid.
and then
Goes down to the ventricle.
when it's in the right ventricle,
Then it goes to the
it goes through
last
the
valve.
pulmonic or pulmonary, because I see them use both names. I don't know
I
why.
use pulmonary.
It's pulmonary or pulmonic, like whatever they put, it's the same thing. Valve from which it goes into the pulmonary artery to the lungs. Now, when blood is coming from the lungs, it enters the heart through the
Pulmonary veins.
all right, from the pulmonary veins, which compartment of the heart?
Left ventricle. Left atrium. Left
No,
atrium.
no. The blood never enters the heart into a ventricle.
Atrium.
It enters the heart always to an atrium.
My fault, I got it mixed up.
Now, from the left atrium,
Goes to the right ventricle.
Right ventricle.
No. blood never crosses from left to
Well, it
right
goes
in the
through
heart.
A series of nonsense, but in the end, it goes.
So
if
how
you have
does-
the right atrium, it would go through what? Left ventricle, right? And then.
So
right
that's
atrium.
outside of the heart. I'm talking about inside the heart.
Okay.
So inside the heart, when the blood enters the left ventricle, where does it go?
You said
The
left ventricle, left atrium.
No.
Yeah, I get mixed up too. It goes from the left
Like
atrium.
It enters from the left atrium.
Bicuspid.
It enters the bicuspid valve, for which another name is
Mitral.
mitral valve, which is what type of valve?
Arterioventricular? No.
Atrioventricular valve. And then it goes to the left ventricle, which contracts, and then the blood lives through which valve?
Aortic valve.
It lives through the aortic valve. Now, what type of valve is the aortic valve?
Atrioventricular?
No.
There's another one.
Both the aortic valve and pulmonary valves are what type of valves?
Oh,
H what?
Half moon.
Semilunar?
Semilunar valve.
Semilunar. Sorry.
And what is the other one? Aortic and?
Both aortic and pulmonary are pulmonic valves or semilunar valves.
They're one and the same, right?
No.
You
The
said
aortic,
pulmonic valve and
the aortic,
semilunar
the aortic is always on the left side.
No, I mean the actual word.
Yes.
The
Semilunar valves.
is semilunar. Pulmonic is semilunar, right?
Yes. Pulmonic is semilunar. Aortic is semilunar.
You
Did
should
I-
write it down. for
They're
them.
called differently, but their collective name is semilunar.
I wrote it down. I was just rewriting it.
I shall write it down.
So
Can you say that
Nothing.
again? The pulmonary valve and the
I shall write it in front because everybody's.
Yes, Steve, did you
Fix that.
finish? Did you already finish all the circulation? Like the.
Yeah.
Alright, so now, because this is a study session. You guys didn't come down here to get lecture again into what Nuki just said, right? So, one of the ways that we learn is by teaching.
Right.
It always helps. So, we just learned the system. Now, everybody's gonna take a turn to come up front and say the exact same thing in like a summary in their own words. Put it in your own words. When you say it in your own words, that's when you understand it. Alright, so like Steve's already went, I already went, so now you guys like, I know who wants to go.
what do you want the circulation of how the
Can I
blood
use
flows?
this?
Yeah, you could use whatever you want. You could use the Sharpies, you could use...
Are we gonna go over nervous system?
Yes, we're definitely gonna go over the nervous system, like, of course.
I can care less about the nervous system. That's like 20% of it.
It's
Trust me, it's the easiest thing.
That's what I'm saying, but it's so minimal.
We'll divide it. We'll divide it. You copy
There
it
is
down
7
and
questions.
How about systole?
7
and
questions on the
10.
test. No, 7 questions. 33 questions of the circulatory system.
And
7
10.
questions.
I could have swore it was
You know what it is,
right?
Contraction.
So,
Diastole is when you have
so wait, now,
Oh,
so like,
relax.
Steve, you done?
I'm
No,
writing
I
one
don't
day.
know that.
when
That's
it's
what I'm
contracted.
Yeah.
Systole would be the actual contraction, the pressure during that.
The aortic and the pulmonary is the semilunars, right?
At 5?
Yeah.
At 5?
Alright.
Okay. Because I was gonna make you go first.
So
Because you have to go. When you have to go, you're gonna go first.
I'm gonna cut the video out.
Don't cut the video off. Like, what are you doing?
I was gonna make a part 2.
It's so that he can send it like easier.
Oh, so that
Oh,
goes
so you can
faster.
send it easier? Okay.
Because he can send multiple.
The more the merrier.